Welcome to our video on bidirectionality and stacking RNNs. Here we'll learn various ways of combining individual RNNs for improving performance. First, we'll go over the notion of loop unrolling or unfolding, which will help us visualize the next topic, bidirectional recurrent neural networks. We'll also show how to increase the depth of our RNNs by stacking them one after the other. To illustrate the concept of bidirectional RNNs, we first need to define what we mean when we say we want to unroll or unfold the computational graph. As an intermediate step, let's show how we've been visualizing the process of the sentence, I like dogs. The RNN accepts tokens one at a time, so we begin with the first token, I. The hidden state used to compute the output is hinit, often all zeros, since we don't have any previous state. Next comes the word like. We use the same set of weights to compute the output, and we use our previous output as the hidden state as usual. We proceed similarly for the last word. Instead of visualizing this with our network moving along the input sequence, we could also just show copies of our network for each input token, with the understanding that each copy has the identical set of weights as all the others. The weights are tied or shared, similar to how we thought about the kernel in convolutional neural networks. Note that this is functionally identical to the above version, it's just an alternative way of visualizing it. Now that we have some familiarity with visualizing our RNNs with loop unrolling, we can make a diagram of a bidirectional RNN. First, we show the forward RNN, which is exactly the same as what we're used to. It starts with the leftmost token in the sentence and works its way to the end of the sentence, left to right. A bidirectional RNN also has a backward RNN, which starts at the end, or rightmost input, and works its way to the beginning of the sentence moving right to left. To obtain the final output sequence of the bidirectional RNN, it is common to concatenate the outputs of the two RNNs at each step. The motivation for the addition of this backward RNN is the observation that we often interpret the meaning of words not only based on the words that came before, but also the words that come after. Consider the sentence, I read the bill. The interpretation of the word bill is going to be very different if the full sentence is, I read the bill recently passed by Congress, compared to, I read the bill from my phone company. A model that interprets a word solely based on the words that came before it would find it difficult to distinguish between these two alternatives. Finally, we can easily implement this in TensorFlow by using its bidirectional dynamic RNN in place of dynamic RNN. We must also know to specify both the forward and backward cells, as opposed to just the forward cell. In most cases, the cells will have the same type of architecture as is the case here. Note that the outputs tuple returned by the bidirectional RNN is actually a tuple of the forward outputs and backward outputs, so we will usually concatenate them together immediately after. We'll go over this bidirectional dynamic RNN in more detail in the final video of this section when we use it to make our advanced version of our text classification model. Similarly to how we introduced the backward RNN in the bidirectional case, we can instead introduce another forward RNN that is connected to the outputs of the other forward RNN, instead of connected to the inputs. Let's see what I mean by this. First, we see the familiar forward RNN, but now I've inserted zero index superscripts to the states to indicate that this is forward RNN number 0, or layer 0. What's new is that we can directly connect these states to another forward RNN, like so. This new layer processes the outputs of the previous layer in the same way, and outputs its own sequence of states. Note that although there is of course some delay between feeding the input word to layer 0 and outputting the computed state to layer 1, we think of them conceptually as occurring at the same time step. In other words, you can think of the process as, start by feeding in the first input token, wait until layer 1 receives the output state of layer 0, let layer 1 compute its output state, and then proceed to the next token, and so on and so forth. In TensorFlow, we create multi-layer RNNs by using the multi-RNN cell, which accepts a list of individual RNN cells in its constructor. It will connect them in the manner shown in our diagram, and its outputs will be tuples with length equal to the number of layers, connecting the outputs for each. It's up to us how to proceed from there, but typically we only use the outputs and final state of the last layer. If you're wondering whether we can combine the idea of stacking RNNs with bidirectionality, the answer is yes. We'll save the implementation for that for the last video of this section, so stay tuned. As always, make sure to read through the links here for an in-depth look at the topics covered today. In the next video, we'll work on implementing a basic text classification model on the 20 newsgroup dataset, as well as going into more detail on the various subtleties of building RNNs in TensorFlow. See you next time!